thanks everyone. Thank you to Paul for making most of my presentation obsolete, so I can hopefully skip through some of it and get to the coffee break as soon as we can. I'll try to avoid any repetition. But also to Charles and to Adam for an excellent conference so far. I think the speakers have been excellent quality, very good mix of stuff, and I'm pleased to see, I think, 5 or 6 presentations of people actually manufacturing in the UK. There's a lot of talk these days about design, but actually people manufacturing stuff in the UK is brilliant to see. So I'm the Commercial and Innovation Director for Alta Technology. I'll give you a quick talk about effectively what OSAT means, where we sit in the value chain, what the landscape is, and then how do we move forward and really progress this within the UK. So Alta Technology, we are part of the TÜV Nord Group, German company, and we sit within the digital and semiconductor business unit, which was just reformed at the start of this year. So we're the semiconductor part of it. The digital part is anotanother company called TÜV IT, who focus on digital security. But Alta UK are a wholly owned subsidiary of that group. So Alta Group has businesses all over Europe. The packaging side is based in the UK, there in Livingston. So all of our packaging and assembly in Alta Group is in Livingston. We have other businesses there in Germany, Spain, and France who focus on things like procurement of components, especially for space customers, testing, qualification, etc. So as a group, we are able to offer a full OSAT service. My credentials and background to talk about OSAT. I started my career at LTEC Semiconductors down in South Devon. Was with them for 12 years working in testing before I moved into sales. And then I've worked for Carsem and ASE, two of the high volume Asian OSAT assembly houses. But I was always in the European sales teams for them. And then I joined Opticap in those days, and we then became part of Alta Group. So I've been with Opticap / Alta for about 7 years. So I've worked in test, I've worked in packaging. I think one of the biggest trends which we've observed that Paul also talked about is that packaging and assembly was effectively dismantled in this country over 20 odd years. It all went to Asia, almost all of it went to Asia, and it was treated as very much a commodity thing. The package does not add much to your device performance. It's just a way to encapsulate and protect your chip to then solder it onto a PCB. That is now changing, as Paul very fluently showed in his presentation. So the package now adds a lot of elements into the device performance, and that's combined with the chip shortage is then bringing a lot of opportunities for people in Europe and UK to really come back into packaging in a big way. So what is an OSAT? We used it in the title of my presentation. OSAT is outsourced semiconductor assembly and test. So we're effectively a third-party company that a customer will go to and pay us to do your assembly and testing or packaging. I think in the old days it would have been classed, the OS would have been offshore. That probably was true throughout the 90s, etc. But outsourced semiconductor assembly and test, we're an OSAT, we're based in the UK and Europe, so we're onshore, but we're outsourced. So we're independent, we don't compete with our customers, we don't generally make our own products, we're a subcontract service, and we sit there in the value chain. We've heard a lot about the front end of the value chain this morning, so the chip design, the wafer fabrication, providing substrates and epi. So that is a very simplified version there of the front end of the supply chain, but my purpose is really just to show that full supply chain. OSAT incorporates everything in the back end. So we receive customers' wafer, we can do wafer testing, wafer thinning, dicing, packaging, and then the final testing again. So customer can send us wafers, and we will return to them finished packaged devices that can be can be soldered onto a board or into their application. So everything in the kind of red, pinky colour. My apologies if that's very difficult to read in the middle there. We don't generally get involved in distribution or system integration, etc. We leave that to our customers. So who are the users for the packaging for the OSAT services? So to try and sort of expand the value chain slightly, you have to look at the customer's business models. So every semiconductor company works in it, has a slightly different business model, whether they're just designing a chip as or even just providing an IP block. They might not get involved in the physical chip at all. So you have companies like IDMs, the very large names in Europe, people like Infineon, NXP, STMicro. They're integrated device manufacturers. Their business model is to do everything in-house. They design, they fabricate the chips. They often do the packaging and tests, although they may outsource that. Then you have wafer foundries who only do the wafer fabrication as a business, IP design. And then where it gets really interesting for OSAT is the fabless and chip designers and the supply chain aggregators and the system integrators. So this is where our core customer base is. To be honest, we don't get involved much with the IDMs. They're very large. They do all of their packaging in-house or in Asia, generally speaking. But the bottom half of the chart there, this is where it gets really interesting for us, and this is where Europe and the UK can really excel in providing a service to these kind of customers. There's some examples there at the back, at the end. It's not meant to be exhaustive, it's just to give a flavour of the kind of people who are there. So what I've tried to do here is try to show a range of different styles of customer according to their cost and the volume expectations and the cost expectations. So from high cost and low volume down in the bottom corner here to high volume and very low cost at the top there, just to show where the opportunity is in the UK and Europe and where the need is. So at the top corner you have those IDMs I mentioned, people like ST, Infineon, etc. Then you have the automotive guys, slightly lower volume but still high. Still very low cost. And then in the middle there you have the kind of the fabless chip companies and designers. So these guys are medium cost, medium volume. And then in the bottom corner we have people like the OEMs. So people making big pieces of equipment, be it scientific, medical, it could be an aircraft, it could be a satellite. So generally these people are making very large systems, and the application is forcing them to go and find some kind of custom ASIC or custom device or system in package, for example, that's really driven by their application. And I think Paul mentioned that the applications are now driving advanced packaging. So what we see there is that the people in the green square, very well supported historically in the UK and Europe with low volume but high cost packaging. The guys in the middle in the blue square, there's a desperate need for more support. Some of them can talk to Asia, some of them might aggregate some of their volumes and go to Asia, but it's very difficult for them, and that's really where we see the need to support these people, these customers in the UK. And everyone in the yellow square, they outsource to Asia. I don't think there's anything we can do about that. So we have enabled medium volume and medium cost packaging in Alta UK by adding a plastic packaging line for QFN and DFN devices. So that's now in production. And we have a volume of around 10 million units per year. So again, medium volume. But we are now seeing a lot of traction with customers who find it very difficult to go to the large OSATs in Asia. But what we're seeing more and more is the need for advanced packaging in the UK, and it's driven by these people in the bottom corner who really can't go and knock on the door of the Amcors and the ASEs because their volume is just too small. So what does the landscape look like worldwide? This is a chart that I stole from Yole, looking at the top 25 OSAT companies in the world by revenue. So at the top you have my former employer's ASE, and somewhere in the middle is Carsem. So there's no European packaging company or OSAT company in the worldwide top 25. Their capacities are dominated by consumer, mobile and automotive, and even in the chip shortage you saw that the automotive guys were struggling to get support, even though they're one of the highest end-use markets in the world, they were still struggling to get support. Very difficult to access unless you have volumes of billions per year, basically, and that's not it's not being flippant. It literally is billions per year. Millions, maybe able to do it. So there's no European company in the top 25. So what that creates, if you put on the chart all the worldwide OSAT suppliers, packaging suppliers, and test suppliers. If you have low volume, this is done by number of suppliers and quantity. If you look at very low volumes, you want 1 unit, 10 units, up to about 10k units. There's lots of support. You can find people to do that. If you have millions or billions of units, there's lots of support. You can get that in Asia. In the middle there is the valley of death, where it's very, very difficult to find that medium volume assembly, and that's really where our target market is, and that's where we hope we can support the industry. If you go to Europe or the UK, then you no longer have the valley of death because you don't have the millions. You fall off the cliff and it never comes back up. There's no one doing that kind of volume, and the UK would be even worse than the European landscape. The only notable exception is Amcor in Portugal. They're not a European company, and they are more and more running their business, so I understand, against the kind of Amcor way of life. So you have to support very large volume customers, and it's difficult to access for smaller customers. So in Europe, it's very difficult. If you looked at this in terms of advanced packaging, it would be even worse. So if you look at European OSATs, this is a list which I took from a report. I'm afraid it's not my list. What's happened there? I'm afraid I didn't acknowledge the report, who the report was from. But if you're interested, let me know and I can get that information to you. So it's not my list, but what you observe is that there's around 20 OSAT-style companies doing packaging and test in Europe, and these are industrial subcontract suppliers. I didn't include anything like there are obviously catapults, universities, and other pilot lines who are doing packaging. These are industrial companies. What you note there is that quite a few of the companies listed are not actually OSATs. They don't do packaging, or they don't do the testing in-house. So some of these people will be more described as supply chain aggregators, the likes of Rude Microtech, for example. They'll do the testing in-house, but they will outsource. They will offer a full turnkey solution, including packaging, but they will outsource the packaging. So what you get if you use a European OSAT rather than trying to go to a large Asian OSAT, of course, we will be probably more expensive, unfortunately, but there are a lot of other benefits. We're much closer in proximity. We speak the same language. We're in the same time zone. We have a very strong collaboration. You can talk directly to our engineers. We have a high level of quality and accountability, and of course the big push at the moment is for sovereignty. So we hear a lot of customers saying we can get this done in Asia. We are getting it done in Asia, or we have been, but we really need, because of the sensitivity of our application, we really want that to be done as close as we can to home. UK ideally, Europe if not. But effectively, as Paul very well said, and has been talked about several times today, we are seeing our end customers, those system integrators, pushing more and more for advanced packaging. So we're hoping to do more and more of this. I think that the very low cost packaging is being overtaken by advanced packaging, and my real point is that it's those system integrators, it's the applications that are driving advanced packaging. It's not the chip designers or even the foundries or anyone. It is the end application that are driving us for advanced packaging. So how do we get there? We need an ecosystem. The OSATs and all the packaging companies can't do it all ourselves. I wish we could. I don't know why that's skipping forward, sorry. Traditionally, an OSAT, a packaging house, will do the things that are in the green square. I'm sorry, that's very difficult to read. But it says in the bottom left, assembly, and then testing, etc., reliability test, failure analysis. But as Paul rightly said, there's all of those things in the orange square that you need as part of your ecosystem. You need the co-design, which means chip, but the substrate and the interconnects. You need the model for power and thermal management. You need electrical modeling, etc. So you really need this whole ecosystem, and then you need the suppliers. You need advanced substrates. To my knowledge, there are no advanced substrate suppliers in the UK. We did a market study at the end of last year, and that showed that there were no advanced substrate suppliers in the UK. And you also need next generation interconnects. So things like bumping, wafer bumping, RDL, TSVs, interposers, etc. This ecosystem does not really exist in the UK. We are trying to put it together. If anyone has any ideas, wants to collaborate, please let me know. I think the closest people to having this kind of ecosystem really nailed in Europe is IMEC. So what do we need to make all this happen? So to bring advanced packaging in a meaningful way, which means an industrial packaging line, we need to develop that ecosystem, the code design, the supply chains. We need volume. So the volume means we need industrial packaging lines, not just pilot lines. I think there are two very distinct things. Pilot lines are seen as being bridging the gap between R&D and going to Asia. That's not the way it always is. Our customers may be designing something for an aerospace application. It will never be millions of parts per year. They're not going to go to Asia. They simply don't have the volume. So they need an industrial packaging partner that can provide quality year in, year out. But it's not pilot lines. This is an industrial packaging line that they need. We need innovation, which means we need ideas, we need collaborative partners, and we need funding. And for that industrialization, we need a level of automation. It's not necessarily robots running around the factories, but it is things like replacing tools with newer systems, automatic wire bonders, automatic flip chip bonders, and things like this as well. So that needs CapEx. So we need investment. I fully echo what Andrew was saying this morning about the funding. We don't see opportunities for CapEx funding. We do collaborate in CR&D projects. If anyone would like to collaborate on CR&D projects that involve packaging, please let me know. These things very often don't cover CapEx. Exactly what Andrew said this morning. If you were to get an investment of £5 million into CapEx or even shared funding, we could do an awful lot of things with that money. We know how to use the equipment. We have the customers. We have the need. We could give a very good return on investment for that kind of investment. So we've already started. This is what our roadmap looks like. Over the last few years and through COVID, we developed the QFN packaging platform in Livingston. So this is now available. It's qualified up to space standards. We've run a qualification project with ESA to qualify QFN package for space applications. We were also influential in writing the standard for ESA standard for qualifying plastic packaging. So we have that available in both single die and multi-chip QFN modules, and we have capacities up to 10 million per year of QFNs. We're entering a project shortly to develop the optical QFN, and then we're now starting to launch the development for the substrate-based BGA, so the second line there. The QFN package is generally very limited in terms of its complexity and its pin count. It's based on a copper lead frame. The BGA line will be using a much more complex substrate, and that will enable the wire bonded, flip chip, and system in package, etc. And you can see there who are driving the need for these things. So the single chip BGAs are really being driven by the fabless and ASIC design companies. The system and package multi-chip modules is really being driven by the equipment OEMs, the system integrators. There is a distinct difference. There seems to be a distinct difference between those two use cases. The fabless companies and ASIC companies, they will still try and do everything on a big system on chip, single monolithic system on chip, whereas the OEM system companies, they already have their system spread across multiple chips. It's just in multiple packages, so they have more interest in doing that. It's just my judgment. And then the third line there is optics. So we have recently launched a project to start developing co-packaged optics for a space application. So we have a line of our business where we're developing optical transceivers for space applications, a standalone transceiver in housing, and now we've got a project funded to investigate how to mount that transceiver. We have a small optical subassembly which we can consider as an optical chiplet, which we're then put into mount. We're going to mount that onto a system and package substrate, so it can be then co-packaged with other elements of the system. So it'll be packaged with the customer's ASIC or FPGA. I think that's it. Thank you very much.